Good afternoon, everyone. Hope you guys are enjoying and watching lessons at Lay Professor channel. In this lecture, we're going to be discussing about classes and objects. Before we discuss in detail the concepts of class and object, let's see some day-to-day life examples. Say, for example, cow, a dog, a hammer. What do we understand or see from these different kind of things? That they have a certain kind of visual representation or tangibility in them, or you may also say that they have certain boundary or they have certain visual impact. Okay, so as these objects understand, we understand these objects in day-to-day life, that we name those objects or those things. Say this animal, particular animal, we named it the cow because it has certain characteristics of cow. And in the same way, this another animal, it has a different characteristics, and those characteristics belong to a dog's characteristics. Okay, and that third example is an object which is a hammer, or it has a characteristic of a hammer, right? Now these three different categories, and we have three different objects. All right. Now these objects, they may have other characteristics. For example, the cows, they may fight with each other, they may not. Don't worry about this diagram because I couldn't find appropriate diagram. So think that this animal is cow, which they are fighting with each other, for example. Usually cows, they don't fight, but just for sake of saying and making the concept understandable. So in other words, that some kind of characteristics, dynamic characteristics associated with each object. Okay. In the same way, the dog may sit to the other side, okay, and it may also bark. You can use hammer, you can use hammer. So that's like a that was a static that you are representing. Here you are using this hammer, so it's in action, the object in action. Okay, so what do we understand? That the objects, they may have an action associated with them, right? Now these are physical world objects, but when we conceptualize things in the same way we conceptualize when we develop engineering systems, or let's say software, for example, that the group of things, okay, which belongs to a, or which share the common property, we may represent those group of things with a name or with a group or with a type. Okay, and we can say that's a class, for example. Now let's go forward and let's try to understand. Okay, cow may be, this is a black color cow, it may have a different other color. In the same way, dog may have a different color, and in the same way, hammer may have different color. Okay, so what do we understand? We understand that each object, they have a state, a particular state, their regular, natural, default state. They may go into a different state, or they may have a behavior. Behavior is nothing but which is we see as the objects, they change. For example, here the cows are fighting. So that is a one behavior, but they may have other behavior, like the cows, they give milk. That's another behavior. So the same object is transiting into a different state, a dynamic state, right? And each object, they have their own identity. Okay? You may say, okay, this name, for example, this cow's name is A, and the red color cow name is B. So you are basically distinguishing different objects with a name, or in other words, the identity of an object. Okay. So these are, in day-to-day life, we see different objects. Okay. Now, if there is an object, there's gonna be a class. Now, what we understood that objects and classes are tightly woven into each other. So if there is an object, there is a class, and if there is a class, there will be an object. Okay. Now, what do we understand with an object? Well, first of all, it's an instance of a class. Second thing, something visible or tangible. Well, that thing visible or tangible in terms of physical world objects, but say virtual world objects, they may be visible by eye, but they may have a concept. So here, understand that is the object, they are representing a certain behavior, and the concepts are the classes in sort of way of understanding that, okay, I have this concept, and if I apply that concept, that becomes an object. Okay, so object can do message passing or can take action. Something that may be comprehended intellectually. Okay, and as we already said that objects are something towards which an action is directed. Okay. Also, an object has a state, and state is nothing but it is the static property or the current value or the default value of the properties what an object may have. So that becomes an state. Okay. So it has all the properties and the current value for the dynamic properties, and that becomes an state. And a behavior, how an object acts and reacts. Okay. Or you may also think of the state is the cumulative result of the behavior of an object. Okay. An identity, a property which distinguishes between different objects. For example, let's say this is a pixel on a screen. All right. So this pixel has a color and it has a coordinates. Okay. Now, if I superimpose another pixel onto it, so location would be same, but the identity of both pixels will be different. Okay. How do we represent? So let's take an example. This is a typical UML notation, Unified Modeling Language, which is quite popular for modeling classes, objects, and interaction between them. So it's a framework. It's a modeling language for widely used in software design field. Okay. So let's say we want to represent dog, a class. So dog is a class name, and then what attributes this dog may have. So dog may have a name, honor, color, address, weight, type, whatnot. Okay. So basic idea is the important characteristics of that class. Now, this is at one abstraction level, but if you say an animal, then dog may inherit properties of that animal class. Okay. Now, let's say this black and brown dog, its name is Tommy. So that, let's say that becomes its identity, that he's Tommy. Who is the owner of Tommy? It's Tom. What is the color? What is the address? What is the weight? What is its type? What kind of dog it is? Let's say German Shepherd. 20 kgs, For example, maybe Tom is not giving good food to this poor Tommy, very low weight. So as you can see here in this typical example, that an instance of this class dog becomes an object, which is Tommy. Let's say another example, or another object of the same class. Okay, its name is Schneider. Owner is Bosky. Okay, color, address, lives in San Jose, and its type is German Shepherd again. So see how these two objects, they have the same class, or they are instance of the same class, but two different objects. Now if you want to implement in a programming language, so let's say this is a C++ example. Okay, so class dog, we have some public members, or so these functions are basically for each class or object to represent and to have the data storage. The typical functions are used, constructors and destructors, and you may have other functions associated with this class. Okay, or some the basic idea here is that the private members means that the objects of this class, they are only gonna access the private members. Okay. So they may have different properties. So basic idea here, we're not going to go in detail how to implement in a particular programming language. You may watch my other lectures on C++ programming, but the idea here is that how we can represent it. This is UML, modeling world. This is implementation world. Okay, the same class and the object. So when we're gonna say use this object in our program, we will simply use it. Say dog is a class, and we create an object. Let's name Tommy. And then we can use this Tommy object or the dog object. Say if we want to modify the property of Tommy, let's say Tommy object. Okay, dot, and it has a weight. Okay, so that's more sort of implementation oriented. But when we analyze and model, our attention is more onto conceptual level. When we have intelligently identified all classes in our complex software system, implementation, it just follows that. So as long as our modeling and design is good, we're going to have good implementation. So what we learned from this discussion, another important point, that objects, they have roles and responsibilities. Okay, and those roles and responsibilities of the objects may change. For example, a bank account, an object, that may have role of monetary asset. Okay, like you have you use your bank account on a regular day-to-day basis. You put some money, you deposit some money, you withdraw some money, so that acts as a monetary asset. Okay, another example, say think about a stock trader. So for a stock trader, stocks are just some quantities or some entities which are bought and sold. That's it. That is a view what a trader sees on a stock market. However, at the same time, those same stocks, they represent a different kind of instruments, say legal instruments, to a lawyer, which have certain rights associated with it. Okay. And let's say for an investor, those stocks represent a tiny fraction or tiny piece of business, right? So say a different object may have a different role for another object. Another example, in a typical day, a woman, she may play a role of a mother, a wife, or a grandmother. Depends. So what we learned from this discussion is that objects have roles and responsibilities. Okay. How do we make relationships, or how do objects relate with each other? Okay. So common form of relationship is link. It's just like link is nothing but a connection. It may be physical or conceptual connection. For example, on your social media profile, you have links to your friends. Okay, so those are, online. It's a conceptual link, and even in fact in concept too, you are linked with your friend. Okay, so it's not that you are physically bound with your friend, but it's a conceptual link. Same way, there are conceptual links between objects. Okay. Let's say an example of an oil controller in a car. Okay. So oil controller, engine, and a valve. Okay. Oil controller is linked with a valve. That oil controller can send the message to valve, another object, that okay, adjust it. And the valve and engine are linked, and oil controller is linked with the engine as well. So this is a conceptual linking, right? Now valve is sitting in the engine, so that may have a physical link here. Okay. Let's take another example of aggregation. The objects may link with each other via links or via aggregation. What is aggregation? It simply denotes a whole and part hierarchy. Okay. And ability to navigate from the whole or aggregate to its part. For example, human body is made of different parts. Say, for example, mind gives signal to our hands for movement. So in one or the other way, it's linked. Another way you can think of the human body as a whole or aggregate is linked with its parts, say mind, hands, eyes. Let's say an example that a temperature controller, okay, temperature controller object, it has a heater, okay, for example, a small heater inside it, and it is functioning, and it is also connected with the temperature ramp. And notice here that the heater is a part of temperature controller, and this diamond, this is a diamond shape, is showing that the aggregate relationship. And this is a UML notation again. So basic idea here is that the objects are linked via links or via the aggregation. What we learned about the class, simply if there is a single object, so an instance of a class, or if there are multiple objects, they may have, or in general, whatever object you see, that's an instance of some class. If two objects, they do not share something in common, you don't put it in one class. So common structure and attributes, they are in one class. Otherwise, you don't put the objects which don't match in one class. Now, how a class or an object, so remember we would be interchanging these terms, class and object. Okay. So think about the object is a representation of a concept or class. Okay. So how do they interface among other classes? So that interface can be divided into 4 parts: public, protected, private, package. Public means everybody can access everything. It's like going on social networking website, whatever your photos, videos, everybody can see everything. Protected means you have given permission to view those photographs, videos to your friends. Private means you only can watch those videos or photographs which you have put on your social media profile. Public, protected, private. And packages, for example, different classes are packaged together in one package and they are interacting. Relationship between classes is important too. So in what ways the classes are related with each other? There may be association, inheritance, aggregation. So we already learned about aggregation. Let's talk about association. For example, a vehicle and wheel. So vehicle may have many wheels, but a wheel belongs to a vehicle. So there is a one-to-many relationship between vehicle and wheel. Okay. So one vehicle may have multiple wheels, but wheel belongs to only one vehicle. Say example of an association. Inheritance. Let's talk about inheritance. This is very similar to like you inherit the property of your parents, right? And you inherit the attributes of your parents in the same way. Say for example, 2 classes, vehicle and car. So vehicle is a class, and that vehicle may be a car, maybe a truck, maybe Lamborghini, another type of car, or maybe a lorry or any kind of vehicle. So car is a kind of vehicle. Okay. So car inherits property of vehicle. Car inherits property of vehicle. And see the triangle sign, it's a UML notation again, and here in association we have different representation. Okay. So car is inheriting property of vehicle. Now this is a single inheritance, okay, because car is inheriting with only one class, but car may have, car may inherit properties from another class. Say another class, I say a human, okay, who may be the owner. Okay. Well, instead of calling human, let's call it a owner. Owner is a class, because you may have a company which owns this car instead of a human. Okay, so let's call it a owner. So the car is inheriting property from the owner as well, like this car belongs to which owner. Okay, so it's a double inheritance, right? In the same way, car may inherit property with another class. So that's an example of multiple inheritance. Now it depends on implementation language. Not every language will support that kind of inheritance, but at a conceptual level, that we can say about inheritance: single inheritance, multiple inheritance. Okay. So thank you very much, guys. Hope you have enjoyed this quick and concise discussion about classes and objects. Thank you for subscribing, and those who have not subscribed, please subscribe the Professor on YouTube. We appreciate your feedback and support. Have a wonderful day.